Galvanic cells, you can think about it as flow of the electrons from one beaker to another. This is in simplest words so that it's quite understandable, but what actually did I just say? Well, we have two beakers. One of them has copper ions. We know that ions is charged elements. And zinc, also charged. They both are 2 positive, right? 2 plus. Now, each of the beaker has also electrode. Here is the electrode. And the electrode is called copper electrode. And of course, logically, we have another electrode, which is zinc electrode. On copper electron, the process of reduction is happening because copper electrode is cathode. So this is cathode. Why is it cathode? Because it's charged positively. Therefore, negatively charged, the one that is zinc electrode, which has the reaction oxidation, and it's called anode. So oxidation is happening here. Reduction is happening here. What is oxidation? Let's recap on that. It's when we lose electrons. Why do we lose electrons in this case? Very straightforward. What is the charge of the electron? It's negatively charged, right? So since this is negatively charged and electrons are negatively charged, of course, electrons will be very happy to leave the anode because of their own charge. And they go through. And as I said, remember, the galvanic cells is the free, spontaneous electron flow. So this whole electron flow, which I just showed in blue, right? Electron leave the negative charge. And of course, they go this way, and then they go this way. And of course, they want to go to the positive charge because it's charged the opposite way. So all the electrons will go to the copper electrode. Because they all go to the copper electrode, the electrode becomes bigger. It increases in size. Of course, not very noticeable, but still, since it's growing, basically. Whereas when electrons leave the zinc electrode, it shrinks. By the way, I should mention that there is liquid, right? Of course, this whole thing is based in the liquid. The square that I put in the middle is voltmeter. Why do we even need this? Because you can't really say, if you see the galvanic cell on its own, you can't really say what's the voltage of it, right? How many electrons are passing. But when you put voltmeter, electrons are passing through the voltmeter, and that's the number that you're going to obtain. Now, of course, that's not it. Would be very easy, right? We have a salt bridge. So something like this. So we have salt bridge. What's the point of salt bridge? Salt bridge can have different ions. It can have K plus and Cl minus, right? If we know it combination of K and Cl actually is the salt. Can also be NaCl and so on, but this is the most common example that I gave. So let's consider that one. So now imagine if we are getting a lot of electrons in the beaker with copper, we're getting 2 negative, right? And we cannot make this whole solution negative because electrons are not going to go to it anymore. We need to balance it out. How can we balance it out? Well, through our salt bridge. Positively charged potassium knows, let's call it, they don't really know, but because of the positive charge, and this becomes really negative, potassium will go through the salt bridge to solve this problem because it's to basically even it out. Again, why the solution with copper becomes more negative? Because electrons are going there, and electrons are charged negatively, of course. Whereas on the other side, we're losing electrons. So the solution, because of zinc plus, becomes more positive. What does go in this case? Cl minus to also balance it out. So we can continue going through and going through. Now I want to write out the reaction for each of the beakers. For copper 2 plus, it will accept electrons, which is 2 electrons, and will become copper 0. We know that electrons are negative, so actually, because electrons are negative here, I specifically put that sign here, it will actually be minus, so 2 minus 2 electrons. But we don't show it to teachers, of course. We show exactly what we know what's happening. Electrons are getting accepted. Electrons are moving to copper. Whereas for zinc, zinc was 0, and it gets rid of the electrons. So we get zinc 2 plus 2 electrons. So that's why from that reaction, we know that this is oxidation and this is a reduction. Anode is where oxidation happens. Cathode is where reduction happens. And that's important. That's a very typical question on the test. And that is pretty much it.